Hi folks, as promised I was going to make these videos to show you how I go through naming a structure when it's given to me or creating structures when a name is given to me. And of course we're still looking at our hydrocarbon families, the alkanes, alkenes, and alkynes, which are hydrocarbons containing single bonds, a double bond, or a triple bond in that order for anes, enes, and ines. So here we're going to go through the steps of finishing off the notes that we've done previously. So in row number 4, here we've got a molecule here where we want to identify the longest chain of unbroken carbon. So I'm just going to go and highlight that as I see it from left to right. So I'm going to come over here and see that I've got a carbon, it's connected to another one, and so on and so forth. And even though it turns corners, it looks like this is an unbroken chain of carbons. So remember, we can present you with molecules that are straight chained, that go around corners, that go up and down from left to right. Your job is to be able to identify what the longest broken chain is, unbroken chain rather, and be able to name the molecule accordingly. So here, if I were to number them, I'm just going to take a look. 1, 2, 3, 4, 5, 6, 7, 8. I've actually got 8 carbons here. So I've got an oct something. So I'm going to write that down. I've got an oct of something. But now right away I can see that I've got a double bond right here. So I've actually got an ene family, ene, E-N-E. So I'm going to write that down, that I've actually got an ene because it's a double bond. So I need to also look at where does this double bond, carbon-carbon double bond come from. I need to give it the lowest number designation possible. In order for that to happen, I need to count the number of carbons from the double bond and see which is the shorter path to the end. So starting at the double bond, going left, I see I've got 3 carbons here. Starting the double bond, going right, 1, 2, 3, 4, 5 in that direction. So this double bond is closer to this end. As a consequence, I start numbering my carbon chain from the left-hand side, going along the chain until I've reached the end. So I've got 1 starting on the left-hand side, snaking its way around, and ending at 8 on the right-hand side. So my double bond is sitting closer to the left-hand side end. And I need to be able to tell within my name where I find that carbon. And we have to say from which carbon the double bond originates. So it starts from carbon number 3. So this is where I'm going to put in my name that my 8 carbon chain has 1 double bond starting from carbon 3. Okay, so here's how we build our name. The ENE tells me I have a double bond. The oct tells me I have an 8 carbon long chain. The 3 tells me that I have the double bond originating from carbon number 3. And I only have 1 double bond. Were I to have 2 or more, I would have to then start putting prefixes in front of the ENE to say if I had 2 double bonds, then it would be a diene. If I had 3 double bonds, I would have a triene, and so on and so forth. So that's how we name this molecule when it's given to us. So of course we have to be able to represent this molecule in different ways. So in terms of our structural formula, again, I'm going to write what I see, and I'm going to be literal and show all of the connections, and then I'll also show you the further way to condense it if you wish. Both would be correct if we asked you to do the condensed formula. So going from left to right, I would see a CH3 group, a CH2, then carbon number 3 is CH. Now I have a special double bond, so in my condensed formula I actually will show that double bond between carbons 3 and 4, which is also CH group. 5, 6, and 7 are CH2 groups, ending in a CH3 group. Now I've written all of that out, but these 3 here could also be represented by CH2 in brackets with a subscript of 3 telling me I have 3 of those in order coming out of the CH group there next to the double bond. So that would be our condensed formula. Moving over to the skeletal formula, again, I could either do it by looking at the condensed formula or the structural formula, whichever works best for you. Remembering that when we do a skeletal formula, carbons are at the ends of lines or at the vertices right here at the top. That's also a carbon. The lines are representing the bonds between carbons. So, starting at the beginning, if I'm going to erase, I'm going to count the carbons as we go along, and we need 8 in total because we have an oct-3-ene. Carbon 1, 2, 3, 4, 5, 6, 7, 8. So here are the carbons: 1, 2, 3, 4, 5, 6, 7, 8. So that's my backbone. But remember, I have a double bond coming out of carbon 3. So from carbon 3, I will just draw one extra line between 3 and 4. And here is my double bond for my skeletal formula. Remembering, I do not have to draw the H's, which is why we actually draw molecules that way more often than not as chemists, because it just takes so long to do it the other way. So hopefully this was a good little tutorial as to how to pull apart a structure and to give a name, a condensed formula, and a skeletal formula.